diaphragm designs that we have. In this case, we're going to be going over all the diaphragms that could go into our 2-inch metal pumps. We have a selection of rubber diaphragms, we have a selection of TPE, thermoplastic elastomer diaphragms, we have a selection of Teflon diaphragms. This selection developed over time because as our manufacturing techniques improved and as we identified customer problems that needed solutions, we developed different technologies. So as I walk through this, you'll see kind of the progress of technology over time, as well as just the general improvement of the performance of our different diaphragms for your pumps. The first set of diaphragms we're going to be reviewing are the TPE diaphragms. The original TPE diaphragm that was created was our traditional style, otherwise known as the pie-shaped diaphragm because it looks a little bit like a pie. And this was based off of the exact same design as our rubber diaphragms, which were the very original diaphragm that was released when Jim Wilden first invented the technology. They use the same outer piston, you can see, as well as the same inner piston and the same shaft. The exact same length of shaft for these two diaphragms. This diaphragm operated very, very well, but because of its shape, when it's being installed into the pump, it's required to actually try to invert this diaphragm in order for it to fit within the pump. That requires a lot of effort, a lot of force, and some good technique in order to make that happen. So what we ended up doing was developing this diaphragm, which is the easy install version of our TPE diaphragms. This one, well, all of these are in Sandscreen diaphragms. You can see that this has more of a convoluted shape. See the shape that it has here? And what we found is that when this diaphragm ran for an extended period of time, this is the shape that it took on. It was its natural position. So therefore, we wanted to design a diaphragm that was in its natural position from the very beginning. And what we found, there was a couple benefits to that. Number one was increased diaphragm life because of the shape of it. Number two was the installation of this did not require any inversion when you were putting it into the center section of the pump because of the shape that it has. Versus, again, this diaphragm, which requires to invert it in order to fit it within the pump. They both share the same outer pistons in this case, the same inner pistons. You can see here in this particular size, this shaft is slightly shorter than this shaft. The shorter shaft does not impact the performance at all, except to this particular one help to extend the life of the diaphragm out even a little bit further and make installation easier. The final development that we've had most recently is in what we call our ChemFuse and PureFuse diaphragms. ChemFuse and PureFuse are integral piston diaphragms, IPDs. And what that means is this outer piston plate, you can see, is not exposed here. It's actually been encased in the material of the diaphragm itself. So what that does is it eliminates any trapped area for bacteria, if it's a pharmaceutical or a hygienic type application, and eliminates any area for abrasion to occur. So it would be on the outside between the outer piston and the diaphragm itself. Outer piston abrasion is the #1 cause for diaphragm failure. And so when you can remove that outer piston and not expose it to any abrasion, these diaphragms have significantly longer life than any other diaphragm out on the market. And that is our thermoplastic elastomer line of diaphragms. Now we're going to talk about our rubber diaphragms. These were the original diaphragms that were started by Jim Wilden. So rubber was used at that time because it was the only material that could take the flexing that was required from the diaphragms for this particular design. So he started with some neoprene, Buna, those types of rubbers. So the original design was this one here. This is our standard traditional diaphragm, again otherwise known as a pie-shaped diaphragm because of the structure of it. It is a full stroke design. It uses the same outer and inner pistons as the TPE diaphragms do, and all of our full stroke diaphragms do. And it does, again, use a similar type of shaft as well. The major challenge with this, again, is that it needs to be inverted. So when we look at our diaphragms, rubber diaphragms are well established, a very good diaphragm. long life, but we do tend to lean towards a TPE diaphragm to further extend the life of that diaphragm out further. So the first attempt at extending the life before we had our thermoplastic elastomer diaphragms was a diaphragm called UltraFlex. You can see some immediate design changes here. This had a convoluted shape, much like I showed you for easy install. It also uses a slightly smaller outer piston here than what is in our standard diaphragm, as well as a shorter shaft and a wider inner piston. And what that does is that reduces the stroke and basically helps to extend the life of the diaphragm, but you also do sacrifice flow and performance because of that particular design. So these are the two rubber designs that we have for Wilden diaphragm pumps. So next we're going to move into our PTFE diaphragms. The original diaphragm that we made out of PTFE was, again, what we called our standard diaphragm at that time. Is now a reduced stroke diaphragm for us because we've developed a full stroke version of this. You can see it had a much smaller inner piston, or much smaller outer piston, and a smaller inner piston, and had rubber backup diaphragms to it. This diaphragm was designed, it was the first one of its kind, made with a PTFE material, and because of that, the materials itself did not have a lot of development, and so they were not very good at flexing. They're more rigid, kind of like a Tupperware type material. So over time, as the materials themselves got better, we were able to build the same diaphragm in a full stroke design. So you can see this full stroke design has the common outer piston that I showed you with the TPE and the full stroke rubber diaphragm as well, and uses the same inner piston. So there's all sorts of commonality of parts between this diaphragm and our other full stroke models. Another improvement between this and the reduced stroke is that the backup diaphragm here is actually a TPE material, which again has better flex life and better abrasion resistance than do rubber diaphragms. The benefits of this over the reduced stroke are 20 to 30, even 40% more flow out of the same pump because of a longer shaft and a larger outer piston, just a better design for this diaphragm. The next step, similar to what we had with a TPE diaphragm, is actually an overmolded IPD for Teflon. So this is an overmolded EPDM backer here with a Teflon cover to it that's been bonded to that chemically. You can see these dimples here. These are actually patented dimples that help to extend the life of the diaphragm out by forcing any flex creases that occur to take different angles, and so it's not just one straight line here which has a better chance of breaking. So these are outstanding in food applications and any situation where you have a lot of abrasives in the material that can potentially have some outer piston abrasion occur. So this is our Teflon line of diaphragms that we have for different designs.